talk about solving equations and inequalities with the absolute value. Now we have to make sure our absolute value is equal to a greater than 0 number. If that's true, then we will have our x value be equal to the negative and positive value of a. The first thing I want to make sure that you do before we solve is to isolate the absolute value. I see that the absolute value of x is set equal to 5, so the absolute value is already isolated, and I see that 5 is greater than 0, so that's positive. Therefore, our solutions are x is equal to plus or minus 5. Because if we think about it, if I take the absolute value of 5, I get 5, and if I take the absolute value of negative 5, I also get 5, because we're talking about a distance away from 0. And in both instances, the result is 5, which is why we have a positive and a negative value. In example 2, I have the absolute value of x minus 3 minus 1 equal to 4. I need to isolate that absolute value, so I'm going to add 1 to both sides. So now I have the absolute value of x minus 3 is equal to 5. Well, I know that I'll have two solutions, one positive and one negative. I'm going to set x minus 3 equal to positive 5 and x minus 3 equal to negative 5 and solve, so that we end up with two solutions, which would result in the answer of 5 when replacing our x value. Adding 3 to both sides, I get x is equal to 8. Adding 3 to both sides, I also see that x is equal to negative 2. This last one, our absolute value is certainly isolated, but notice that we end up with equal to negative 24. Because this value is not greater than 0, we would say that there is no solution. Because we don't measure distance in negative values, there's no possible way that the distance away from x could be a negative value when given the absolute value. Example 4, we'll go ahead and isolate the absolute value by subtracting 5 from both sides. Now I have the absolute value of 4x plus 3, negative absolute value of 4x plus 3 equals negative 3. Divide by negative 1. Now I have the absolute value of 4x plus 3 equals positive 3. I'm going to set this equal to a positive 3 and negative 3. 4x plus 3 equals positive 3, and 4x plus 3 equals negative 3. And we'll solve each one. Subtract 3, so 4x equals 0. Divide by 4, x is equal to 0. Subtract 3, I have 4x equals negative 6. And divide by 4, I have x is equal to negative 6 fourths, or negative 3 halves when we simplify. This final one, we'll go ahead and isolate the absolute value by subtracting 2 from both sides. I now have the absolute value of 5x plus 4 equals 3, and then set it equal to the positive 3 and negative 3. So 5x plus 4 equals positive 3, and 5x plus 4 equals negative 3. And we'll solve each one. Subtract 4 from both sides, so 5x equals negative 1, and divide by 5, so x equals negative 1/5. Subtract 4 from both sides, now I have 5x equals negative 7, and divide by 5, negative 7/5. You can also use Desmos to graph these and verify that this certainly is where the graphs are crossing the x-axis. When solving inequalities, our value of a still has to be greater than 0. We're still going to want to isolate our variable, isolate the absolute value before we isolate the variable. However, one of two things will happen. if we have a less than symbol, we will set it up as negative a less than the inside function less than a. Or if it's greater than a, we will set it up as x is less than negative a or x is greater than a. When I look at my first piece, I see that our absolute value is already isolated. I see I have a less than symbol, so I'm going to set this up as negative 5 less than 3x plus 2 less than the positive version, and then go ahead and get x by itself. We need to subtract 2 from all pieces such that negative 7 is less than 3x is less than 3. Divide everything by 3. So negative 7/3 is less than x is less than 1. We see when we're going to graph this that we have the less than symbols. So at 1, I'm going to have an open circle, and negative 7/3 is negative 2 1/3. Going to kind of estimate here. And our x value is in between these two, with both with open circles because we have less than symbols. The absolute value of 5 minus 2x is greater than or equal to 1. I have the greater than symbol, so that means I'm going to set it up as our value less than negative a or our value greater than a. And the similar statements will hold true with the greater than or equal to symbol. So I will set this equal to two pieces. 5 minus 2x is less than or equal to negative 1. Or 5 minus 2x is greater than or equal to 1, and simplify each value. I will subtract 5 from both sides, giving us negative 2x is less than or equal to negative 6. I'm going to now divide by negative 2, and remember when we divide by a negative value, our symbol switches. So I have x is greater than or equal to 3, or following the same procedure, subtracting 5 from both sides, I have negative 2x is greater than or equal to 4. When I divide by negative 2, again, our sign will change. So it flips from greater than or equal to less than or equal to. At 3, positive 3, I'll have a closed circle, and at positive 2, I will have a closed circle. Our x values need to be getting bigger than 3. And our x values need to be getting less than 2. Finally, we have the absolute value of 2x minus 1 over 3 is greater than or equal to 5/6. This is a positive value, and we have the greater than or equal to symbol. So I'll set two different equations. I'll have 2x minus 1 over 3 less than or equal to negative 5/6. Or we can have 2x minus 1 over 3 is greater than or equal to the positive version of 5/6. Now we'll go ahead and simplify. So to simplify, I'm going to multiply everything by that least common denominator so I can eliminate fractions. I'm going to multiply everything by 6. So when I take 6 times my first piece here, I'll have 6 divided by 3, which leaves me with 2 times 2x minus 1 less than or equal to. When I take 6 times negative 5/6, we have negative 5. And we'll continue solving by distributing. So 4x minus 2 is less than or equal to negative 5. Add 2 to both sides. 4x is less than or equal to negative 3. And then dividing by positive 4, we have x is less than or equal to negative 3/4. I'm going to follow the same procedure on the right-hand side by multiplying by my least common denominator to eliminate fractions. I'll still have 2 times 2x minus 1 greater than or equal to positive 5 this time. Distributing, we'll still have 5x minus 2 is greater than or equal to 5. Adding 2, we have 4x is greater than or equal to 7. And x is greater than or equal to 7/4. 7/4 is the same as 1 3/4. So I'll have a closed circle at 1 3/4, and my x values need to get bigger. I'll also have a closed circle at negative 3/4, and my x values need to get smaller. And this concludes our lesson on solving absolute value equations and inequalities.